Imagine you are holding a remote control that can rewind the entire history of the universe. You press the button, and galaxies rush toward one another, stars unburned, cosmic clouds contract back into their cradles. The screen grows hotter, denser, brighter. You keep rewinding past the formation of the first atoms, past the flash of the cosmic microwave background, deeper into a primordial fireball, where matter itself dissolves into a sea of fundamental particles. You are heading toward the beginning, toward what you have always been told was the very first moment. And then, just as you expect to hit a wall, a sharp, definitive zero on the timeline, something strange happens. The remote stops making sense. The concept of rewinding itself breaks down, not because you have reached a barrier, but because the direction you were traveling in simply ceases to exist. There is no wall. There is no boundary. There is no first moment. This is not a fantasy. This is where our deepest physics points, and it suggests something so counterintuitive that it can restructure your entire sense of reality. The universe never began in the way you think it did. In fact, it never had a first moment at all. Let me explain. Most of us carry a mental picture of the Big Bang that was shaped by its name. We imagine a vast, dark, empty void. Then, out of nowhere, an explosion, a single point of infinite density detonating like a bomb, spewing matter into a pre-existing space. In this picture, a clock sits outside the universe, ticking. At time zero, the fuse ignites. That moment, the instant of detonation, feels like the ultimate beginning, the first moment. It is a very human way to think. Everything has a starting point, a cause, a moment when it was born. Your birthday, the founding of a city, the first note of a symphony. Our lived experience is built on sequences, on the arrow of time pointing from a past that had a definite start toward an open future. So when cosmologists told the public that the universe began with a Big Bang, everyone naturally slotted it into that familiar narrative. First, there was nothing, then there was a moment when everything began. This intuition is so powerful that even scientists grappled with it for decades. Surely, they thought, if we run the expansion of the cosmos backward, we must reach an ultimate beginning, a primordial singularity where the density and temperature become infinite and the laws of physics collapse into a single point. That point would be the first moment, the origin of time itself. Many popular science accounts still speak this way, presenting the Big Bang as the creation event. But this intuition, as reasonable as it feels, is almost certainly wrong, or at least profoundly incomplete. The real reason is more fundamental and requires us to re-examine not just what the universe did, but what time itself actually is. Here is where we need to start from first principles. Forget for a moment everything you think you know about the Big Bang. Let's build up the core ideas slowly, like a physics professor sketching on an empty blackboard. When we talk about the universe, we are talking about everything, all of space, all of matter, all of energy, and crucially, all of time. In our everyday lives, time feels like a steady universal flow, a cosmic metronome ticking away independent of events. Isaac Newton imagined it that way, an absolute background clock. But Albert Einstein showed us that this picture is wrong. Time is not a separate stage on which the universe performs. Time is woven together with the three dimensions of space into a single four-dimensional fabric called space-time. This fabric can bend, stretch, and warp in the presence of mass and energy. The rate at which time passes depends on how fast you are moving and how strong the gravity is around you. There is no universal now that sweeps through the cosmos. Space-time is a unified whole, a block universe in which past, present, and future all exist on an equal footing, like points on a map. This is not philosophical speculation. It is verified every day by GPS satellites, which must correct for both velocity and gravity-induced time slowing to keep your phone's location accurate. Now, what does all this have to do with the Big Bang? Well, if space-time is a unified entity, then the beginning of the universe cannot be a case of matter suddenly appearing in an already running time. Instead, the Big Bang must be understood as a condition of space-time itself. When we look out at the night sky, we see galaxies rushing away from us in all directions. It is not that they are moving through space like shrapnel from an explosion. Rather, space itself is expanding. The distance between galaxy clusters is increasing because new space is constantly being created between them. Run that cosmic movie backward, and space shrinks. The galaxies converge. The universe becomes hotter and denser, and the fabric of space-time compresses into a state that, in Einstein's classical theory of general relativity, indeed seems to collapse to a point of infinite curvature about 13.8 billion years ago. That mathematical point is what we call the singularity. On a naive timeline, it would be labeled t equals 0, but here is the key insight. The singularity is not a physical place or moment. It is a signal that the theory itself has stopped making sense. When a mathematical model spits out an infinity, it is telling you that you have pushed it beyond its domain of validity. In other words, general relativity predicts its own demise. It tells us that at the extreme densities and energies of the earliest universe, we can no longer trust classical spacetime. We need a deeper theory, a theory of quantum gravity. This is the point where things get truly interesting. To go further, we must bring in quantum mechanics, the physics of the ultra-small. In the quantum world, nothing is certain. Particles don't have well-defined positions and velocities simultaneously. They are described by clouds of probability. Energy and time themselves become fuzzy at scales called the Planck length and the Planck time, about 10 to the minus 35 meters and 10 to the minus 43 seconds. The very concepts of a definite point in space and a definite instant in time dissolve into a foamy probabilistic sea. Space-time itself becomes quantum mechanical, so the notion of a sharp first moment, a pristine tick of a clock at t equals 0, evaporates into a haze of uncertainty. The closer we try to get to the supposed beginning, the less meaning the word moment even carries. You simply cannot pin down a precise instant of creation in a realm where time itself is a smeared-out quantum variable, much like you cannot pin down the exact position of an electron cloud. A beautiful and profound way to resolve this was put forward in the 1980s by physicists Stephen Hawking and James Hartle. They proposed what is known as the no-boundary proposal, and if correct, this idea gives a stunningly elegant answer to our title question, why the universe never had a first moment. Their reasoning uses a mathematical tool called imaginary time, a misnomer that sounds more mystical than it is. Imaginary time is just a way of treating time as if it were a fourth spatial dimension. In this picture, space-time becomes a smooth, four-dimensional surface, much like a sphere, but with one more dimension. Think about the surface of our Earth. It is finite in area, yet it has no boundary, no edge where you could fall off. You can travel in any direction and eventually return to your starting point. Now, on this curved surface, there are special points like the North Pole, but they are not boundaries. At the North Pole, every direction you move points south. The concept of north of the North Pole is meaningless. There is no edge, no beginning to the Earth's surface. The pole is just a point like any other, just a coordinate. Now apply this metaphor to the history of the universe. In real time, we perceive a past that seems to shrink toward a fiery Big Bang. But in imaginary time, that apparent beginning is smoothed out into a rounded pole, a point on a four-dimensional sphere where the time direction simply curves back into space. Just as there is nothing south of the South Pole, there is no time before the Big Bang. The universe is finite in the past, but has no boundary, no sharp edge, and therefore no first moment. The Big Bang is not a creation event, it is a pole on the space-time surface. This is the key point. Asking what happened before the Big Bang is as nonsensical as asking what north of the North Pole is. It is not that our telescopes are too weak to see the answer. It is not that the information is hidden behind an impenetrable fireball. It is that the very structure of reality does not contain a before in that direction. Time itself was born with the universe in a way that does not require a starting instant. The universe did not begin in time. Time emerged with the universe. Let me offer a few strong analogies to make this even clearer, because I know how slippery these ideas can feel. First, imagine you are watching a campfire. The flames dance and rise, sending glowing embers into the night. You can follow a single ember upward and trace its trajectory back down toward the log. But when you reach the surface of the burning wood, you cannot ask where the ember was a minute before it was part of the log. The ember, as a distinct glowing speck, simply did not exist. The concept of the ember's path ends at the log's surface, not because you hit a magical barrier, but because the very definition of the ember no longer applies. The Big Bang is like that log surface, a frontier where the notion of a linear timeline ceases to be meaningful. The universe did not emerge from a previous state of nothingness. The question of a previous state fades away at the pole. Now, a second analogy, consider a perfectly smooth, polished sphere. Run your finger along its surface. It has no starting point. You can trace a path along any great circle and return to where you began. If you were a two-dimensional being living on that sphere, you could measure its total area. You could walk from the equator to the pole, but you would never encounter a line you could point to and say, this is where the sphere begins. In the no-boundary proposal, the history of the universe in imaginary time is like that sphere. Its past is finite, but unbounded. The Big Bang is simply a well-behaved point on that hypersphere, not a rupture or a moment of creation. It is just a location. A third analogy brings it closer to your own experience. Think about a circle drawn on a piece of paper. You can rotate your finger around the circumference endlessly. There is no corner where the circle starts. Even though the circle is finite, it has no beginning. In a similar way, the universe's timeline, when viewed through the lens of quantum gravity, wraps around the Big Bang pole, making the notion of a first moment dissolve into a continuous closed geometry. There is no t equals 0 boundary condition because the universe is self-contained. At this point, you might be thinking, that's a beautiful piece of theoretical mathematics, but what connection does it have to the real observable cosmos? The answer lies in the sky. When we look out with instruments like the Hubble Space Telescope or the Planck satellite, we are looking back in time. The light from distant galaxies takes billions of years to reach us, so we see them as they were when the universe was young, and the furthest we can see in every direction is a wall of light called the cosmic microwave background. This is the afterglow of the Big Bang, the cooled down radiation from about 380,000 years after the apparent singularity, when the universe became transparent. That glow is not coming from a single point. It bathes the entire sky, arriving from all directions uniformly. This is exactly what we would expect if the Big Bang happened everywhere at once, not at a specific center in space. The cosmic microwave background tells us that the early universe was incredibly smooth and uniform, with tiny ripples that grew into the galaxies we see today. This uniformity is a problem if you think of the Big Bang as an ordinary explosion, but it fits perfectly with a model in which space itself expanded and the initial conditions were set by a quantum process that smoothed out any sharp edges, including temporal ones. The Planck satellite data gives us a map of those primordial ripples, and their statistical properties are consistent with models of quantum fluctuations stretched to cosmic sizes, models that naturally connect to a no-boundary beginning. Real-world experiments continue to probe this deep history. Particle accelerators, like the Large Hadron Collider, recreate the energy densities of the universe just a fraction of a second after the Big Bang, allowing us to study the behavior of matter when the cosmos was a seething soup of quarks and gluons. We observe that at those extreme energies, forces unify and particles behave as if they have no mass. Extrapolating further back, the physics becomes simpler, more symmetric, until we reach the Planck scale, where time itself loses its classical meaning. Space missions, such as the James Webb Space Telescope, seek to detect the very first stars and galaxies, providing a narrative of structure formation. But none of these tools can literally observe the Big Bang itself, because the Big Bang is not an observable event located on a timeline. It is a limit of our classical description. The fact that we cannot see a first moment is not a technological limitation, but a reflection of the geometry of reality. Now, here's where I want to guide you through a thought experiment. Imagine you have a perfectly accurate, indestructible spacecraft and a pilot willing to travel back in time as far as physics allows. The pilot activates a theoretical time drive and the external universe begins to contract. The temperature rises. The cosmic microwave background blue shifts into infrared, then visible, then ultraviolet, then X-rays. The sky turns into a blinding uniform furnace. The ship's hull is heated to millions of degrees, but let's pretend the ship survives. The pilot continues further back. The density of matter around the ship becomes comparable to that of an atomic nucleus, then far beyond. The pilot looks at her clock. At some point, the clock's hands start to behave erratically. The very concept of a second stretches and warps because space-time itself is now a quantum foam. The pilot cannot say, "Now we are 1 second before the Big Bang," because the question, "How long before?" has no meaning. The time coordinate she relies on becomes space-like. She experiences the universe not as an evolving history, but as a static, curved geometry. She never crashes into a zero point. Instead, the journey simply stops making sense as a temporal journey. There is no first moment to hit, just a smooth, unbounded surface where the direction of time rotates into a direction of space. The pilot would find herself at the North Pole of the universe, where any step she takes moves her forward in what we think of as time. But there is no step backward behind the pole. The before simply does not exist. Now, let me clarify some of the most common points of confusion people have when they hear about the Big Bang and the beginning of time. First, the Big Bang was not an explosion that happened somewhere in space. It happened everywhere. The expansion of the universe means that any 2 points in space are moving apart. If you picture a loaf of raisin bread rising in an oven, the dough represents space and the raisins represent galaxies. As the dough expands, all raisins move away from each other. There is no special center raisin that is the origin of the expansion. Similarly, our universe has no center where the Big Bang occurred. The Big Bang occurred at every point in space simultaneously because all of space was compressed. This means that when we talk about the early universe, we are not talking about a tiny point floating in a void. We are talking about the whole of space being incredibly dense. If the universe is infinite today, it was always infinite, just squeezed into a much smaller volume relative to any given region. So the image of a cosmic egg that hatched at a single location is completely wrong. Second, the singularity at t equals 0 is not a thing you can physically reach. It is a mathematical artifact. When a theory produces an infinity, it is asking to be replaced by a more fundamental theory. In the same way that we no longer say the electron is a point particle with infinite self-energy, because quantum electrodynamics replaced that classical notion, we should no longer say the universe began at a singular point. Quantum gravity replaces the classical singularity with something else, a fuzzy, boundaryless geometry. So when a physicist says the universe is 13.8 billion years old, they are really saying that if you extend the classical expansion of the universe backward, you hit a region where the classical notion of time breaks down at about 13.8 billion years ago. But that does not imply there was a first moment at exactly 13.8 billion years minus 1 Planck time. The entire concept of a timeline near that region is ill-defined. Third, the no-boundary proposal and similar quantum cosmological models do not say that the universe came from absolutely nothing in the sense of a pre-existing void. They say that the universe is a self-contained entity whose structure has no causal edge. The question, why is there something rather than nothing, might not need an answer, because nothing, in the sense of a timeless, spaceless, lawless void, is not a state that can precede something. It is a linguistic placeholder with no physical counterpart. The universe may simply exist as a brute fact, a closed, consistent solution to the laws of quantum physics with no need for an external creator or a trigger. This is not a proof against a creator, but it shows that a purely physical, self-sufficient universe is logically possible and does not demand a first moment to get it started. So now, with all of this laid out, let's return directly to the main question. Why did the universe never have a first moment? Because the structure of time itself is such that the past is finite but unbounded. In the most successful models of quantum gravity, the cosmos is like a four-dimensional sphere with no temporal edge. Just as a sphere has a north pole but no northern boundary, the universe has a big bang but no moment of creation before which there was nothing. The phrase first moment implies a sharp boundary, a starting line drawn across the fabric of reality. But reality at its deepest level does not have such a line. The universe is a complete, self-consistent whole, and time is just a coordinate inside it. The Big Bang is simply the point on that coordinate map where the southward direction ends and all paths lead forward. There is no first moment because the timeline curves back on itself in the quantum foam, making before as meaningless as north of the North Pole. This perspective reshapes much more than a single scientific question. It offers a broader perspective on what it means to exist in a universe that requires no beginning. For centuries, philosophers and theologians argued that the universe must have a first cause, a prime mover that set it going, because an infinite chain of causes seemed impossible. The no-boundary cosmos dissolves that logical demand. The chain of causes is not infinite, but neither does it start with a causeless first event. Instead, it forms a closed, finite loop of explanation. The universe can be its own reason for existing, not because it popped into being from nothing, but because it is a timeless, four-dimensional entity whose geometry simply is. This aligns with what we find in Einstein's relativity. The past, present, and future are equally real. The feeling of a flowing now is a feature of human consciousness, not of the fundamental architecture of reality. If all moments coexist in the block universe, then the Big Bang is not a moment of creation, but a region of the block with a special geometry. It was never the first moment in a temporal sequence. It is just a coordinate boundary where time gives way to space. Now I want you to take a moment and absorb how this reframes your own existence. You were born, you will die, and in between, you experience a linear life. But in the block universe, your entire life is a static world line in space-time, a shape in the cosmic sculpture. Just as the universe has no beginning in time, your own timeline has no edge in the broader fabric, only a sequence that feels directional to you. This is not to diminish the reality of your experience, but to elevate it. You are a pattern of matter and energy woven into a grand boundaryless tapestry. The question, what was there before the Big Bang, transforms from a scientific puzzle into a poetic meditation on the nature of existence. It is a question that in a very real way does not need to be answered because it unasks itself when you understand the structure of time. So the next time you look up at the night sky, let this idea settle into your bones. The light you see from a distant star left that star millions of years ago, traveling across a stretching fabric of space-time to reach your eye. That journey, too, has a history that goes all the way back, not to a breaking glass moment of creation, but to a smooth, silent pole where time curls in on itself. The universe never had a first moment, because the very idea of a moment breaks down where the cosmos rounds off its own past. There is no starting line, there is no cosmic go button, there is simply the universe, finite, unbounded, and complete. And in that wholeness there is a quiet, profound beauty that asks for nothing beyond itself. It just is. If you have enjoyed this video, please consider subscribing and liking to help me out. Thank you and have a great day.